Our learning target for today is that by the end, you'll be able to graph an absolute value function on the coordinate plane. And hopefully by the end, you'll be able to do that without a calculator, but also maybe with a calculator if need be. Let's not forget what absolute value is. This is something that maybe you've seen before in other math classes. Absolute value is the distance a number is away from zero on the number line. So how does that relate to positive and negative numbers? Let's take a look at a few of these. Let's start by just finding the absolute value of numbers and how they will behave on the graph. So remember, the absolute value symbol is just a couple of straight lines down kind of around the number. So that's what absolute value looks like. And if it's the absolute value of 3, how far is 3 away from 0? It's 3 steps, right? It's 3 spots from 0. Now what about negative 3? Again, negative 3 is still 3 spots away from 0. It's just 3 to the left instead of being 3 to the right. So rule of thumb is, yes, it'll always come out as a positive, but more importantly, it's because of how far it is from 0. How far away is negative 15 from 0? You got it, 15. And since I got live people in the room, I'm going to use them. And Andrew, how far away is 17 away from 0? You got it. So kind of obvious stuff here. And how far away is 0 from 0? It's exactly it. So the absolute value of 0 is still 0, a neutral number. Okay? Again, any questions or comments, make sure you type them into the chat. But this one seems to be pretty self-explanatory. So here we go. We have our first absolute value function. How cool that the absolute value makes a V. So in the name itself, it kind of helps you remember what it's going to look like. Now, the absolute value for just simply x is already graphed. And so we're going to compare that. What happened? I lost one. No, I didn't. So we're going to compare that to an absolute value function that has a little bit going on. So we're going to add 3 inside the absolute value, and then outside of it, subtract 2. Now this should look familiar because this is kind of like what a square root function does. Inside the square root we add or subtract, and then outside we do a little bit more. So let's make a table of values that we could use to graph the absolute value. Well, the first thing I'm going to do is just use my graphing calculator. Okay, so I go ahead, press y equals, where you enter your equations. Now the absolute value symbol is something you're going to have to kind of look for here. So the easiest way to get to it is to press the second button and 0. Because second 0 brings up the entire catalog of everything the calculator can do. And the first option is ABS, and that stands for absolute value. So go ahead and use that. And then type in what you have inside the little bars there, the absolute value symbol. So that's x plus 3. Okay? I do have to get outside of the absolute value, so I'm going to have to arrow to the right. So right arrow to get outside, where I can then subtract 2. So minus 2. Okay? From here, let's go ahead and look at the graph. What does that look like? All right, still a V shape, but it's moved a little bit. It's moved to the left and then a little bit down in terms of where it kind of makes that point, the point of the V. So let's go ahead and look at the graph of this. Now, you can see that all my numbers are right in a row. That's interesting. So let's kind of go up a little bit, and I want to find that turning point where the numbers kind of changed. And we're used to this with parabolas. Maybe go one more. So do you see right here at negative 3 where it's negative 2, but then on either side of negative 2 it's negative 1 and 1. Either side of that it's 0 and 0. So that's an important number. The negative 3, negative 2 is its turning point. So let's put that right down in the middle. Negative 3, negative 2. Now to this side of x it always gets bigger. Negative 2, negative 1. And let's go negative 4, negative 5. I'm just filling those out based on the fact that numbers go in order. Now, in terms of the y values, those are always going to be a little different. You can see we had negative 1, 0, 0. So let's go back to negative 1 on this side, negative 1 on that side. And then again, the same number is going to be here because it's making that V shape. All right? And that's all because of the very first example that we talked about, where if we do the absolute value of positive 3 and the absolute value of negative 3, we're going to get the same output. We're still going to get 3. So that's why those y values are the same. So let's go ahead and graph this. Let me change my color. I should have done this a while ago. And so let's plot these points. Negative 5, 0. 1, 2, 3, 4, 5, 0. Still an x-intercept, still a 0 value. So understand, what we talked about in the past with those. 4, 1, 2, 3, 4, down 1, and then 3, down 2. And that's the turning point. That's where things kind of change. That's when I go negative 2, then down negative 1, and then negative 1 and 0. So we've made that bottom of the V. And these do rise 1 and 1. So the rise of these is going to be up 1 and over 1. So let's go ahead and make a V shape. Totally fine here to make a V. Unlike parabolas where they're U shapes, these ones are traditional V. So if we write down the equation, y equals x plus 3 in the absolute value and then minus 2, the x value is always the opposite and the y value is always the same value. And the x value always comes to us from the symbol, so in this case the absolute value, and the y value comes to us from the number that's outside of that. All right. We've only got 2 more of these, so notes are really, really quick today, giving you plenty of time to answer any questions. We're asked to use our calculator to create a graph of x minus 2 minus 1. But let's see if we can determine the vertex without the calculator, okay? So let's determine that turning point. Well, remember, it comes to us from inside the absolute value. So in this case, it's negative 2, but it's always the opposite, so it's positive 2. I'm going to put it right in the middle of the table so I can put numbers on either side. And then the y value is always the exact same. So there we have the turning point. From there, we can fill out the other numbers. We know that these are going to get larger, 2, 3, 4, and these are going to get smaller, 1 and 0. But let's go through the process of putting this in the calculator again so that we can graph it, okay? So in the calculator, go to y equals. You got to clear out what you already have, so get rid of that. Again, how do you find the absolute value? Easiest way, second 0 brings up the entire catalog. A catalog is everything that your calculator can do. Absolute value is the first one, so press absolute value. And then enter in what you have, which was x minus 2, x minus 2. Get out of the absolute value so you can do the next piece, and you'd have minus 1, subtracting 1. Let's take a look at what it looks like. So this time it's been moved to the right and it's been moved down. And that's that turning point. That's that vertex that we were talking about. So let's maybe take a look at the values. Second graph. Now the one that we really want to focus in on is this one right here. The 2 and the negative 1. The turning point we got from the equation. So let's go down there and see that. All right. And look at that. The 2, the negative 1, and then on either side of that is the same number, 0, 0, 1, 1, 2, 2. So let's go ahead and fill that out. On either side of negative 1, there's a 0 and a 0, and there's a 1, and there is a 1. So let's go ahead and graph them. I like starting at the turning point. So that's at 2, down 1. And notice how that shifted from 0, 0. And then we go 3, 0. There's the next intercept, a 0 value. And then 4, 1. And these continue to rise and run at a rate of 1. So there's 1/2 of the absolute value. We go in the other way. So we're going to go positive 1, 0. Again, a 0 value. And then 0, 1. And then these will continue to rise and run in a 1-to-1 situation. So there you go. You've got your absolute value. Now, more importantly, we want to state the domain and the range. We did this last class. If it didn't make any sense, hopefully a little bit more experience with this and it'll make more sense for not only absolute value functions, but also square root. We can't forget that the domain is the x and the range is the y. So let's take a look at our x values. Our x values go left and right. From this turning point, we have all the numbers this way, and we'll have all the numbers this way. So in this case, it's in an infinity situation. So I've got to put less than or equal to, less than or equal to, and then go positive infinity here and negative infinity there. So we're actually including all the numbers in both directions. Now, if you wanted to write that in interval notation, which we talked about, we can go parenthesis, negative infinity, comma, positive infinity with another parenthesis. Just the same way to write what we really are saying, which is all x values. All x values are included. Now the range are a little bit different. We are going to leave some out. And the reason why we're leaving some out is because we're talking about the y values. And I don't see anything in this region right here. There are no points plotted. There is no part of that absolute value function that is below this magical y value right here. So this point right here is -1. So that means everything is above that. So greater than or equal to -1. Now, we had some people want to do this in interval notation last class, which you can totally do. So we're going to say that it's greater than -1. So smallest number is -1. We're heading towards positive infinity. I got some people that want to participate with me this morning. So if you want to write this in interval notation, it would be a -1 with a bracket and then a comma, infinity towards positive infinity with a parenthesis. And there you have it.